mathematicians, here we go. We are getting into lesson 15. We are going to continue working on our long division. I'm going to continue connecting the long division with the modeling because we are being very thoughtful when we're doing this long division. We are not being zombies and just memorizing a standard algorithm and doing it mindlessly. We are thinking about what it means when we have a difference between two numbers. What does it mean to bring a number down? What does it mean when we're dividing something into 3 equal groups? I want you to be very thoughtful during each step of the process. This way, your understanding of this concept, this long division concept, which historically has given humans a hard time, as long as you go through these lessons in a thoughtful way, pausing to think about your understanding, pausing to assess where you are, you will not be like an adult that has bad memories of long division. Ask your parents how they feel about long division. I feel like it's been something that's tortured kids for a long time, but it stops here. You guys can do this. You have all of the strategies, tools you need to be successful with this. Let's just take it slow, take it one step at a time, and let's just really think about what we're doing. That will empower you in a way so that you feel like you kind of have control over this process. So long division, we got you. We're coming for you. Let's do this. Here we go, guys. We are getting into lesson 15 on today, the 4th of October, 2018. Okay, so first of all, we're going to look at this problem, 5/10 divided by 2. Notice in our modeling, it's not set up the same way that it was yesterday. Yesterday, Eureka separated the bottom 2 rows for us when we were dividing into 2 equal groups. Today, we're going to have to do that for ourselves. No problem, we can handle that. So I've made 2 rows here below because we're going to be dividing 0.5 or 5/10 into 2 groups. Okay, up here is where we're going to model 0.5 or 5/10. Over here, we're going to do the standard algorithm. Notice how it's set up. We have 5/10 underneath the division house because 5/10 is being divided by 2, or 5/10 is being divided into 2 equal groups. So let's get going. Let's look at what 5/10 looks like as in terms of modeling. So I have 1, 2, 3, 4, 5/10. We are dividing these 5/10 into 2 equal groups. So I'm going to put 2 there, and I'm going to put 2 here, which means I've used 1, 2, 3, 4/10 with 1 left over. When we have 1 left over, we're going to move it next door. So let's go ahead and connect that to our long division using the standard algorithm. Notice I'm bringing my decimal point straight up. I'm not moving it to the right, I'm not moving it to the left, I'm moving it straight up. So let's ask ourselves, how many 2's go into 5? Or 5, when 5's broken into 5/10 broken into 2 equal groups, how many tenths will I have in each group? I will have 2. 2 times 2 is 4. What is the difference between 5 and 4? It is 1. Just like we did here, we have 2/10 in each group, 2/10 in each group. We used 1, 2, 3, 4/10 all together. And then we have this one, we had 1/10 left over. Interesting, but I'm out of numbers, Mrs. Calamaris. This is the big difference in lesson 15. How many hundredths do I have in 5/10? I have a blank space. Blank space, you guys know, can be replaced with a 0. Blank space is equal to 0. So I'm going to insert the fact that I have 0 hundredths, and I'm going to bring a 0 down. Very interesting. Let's look and see what that looks like in our modeling. So I have 1/10. I'm going to cash my 1/10 in for 10 hundredths. I'm cashing in my 1/10. It's no longer a 1/10. Now it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths. Now I have 10 hundredths, and I need to share 10 hundredths evenly across 2 groups. Well, that looks like 5 for you and 5 for you, which means I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Interesting. Let's go back to the standard algorithm. We inserted our 0 because I had blank space. I had 0 hundredths, so I made a 0 because I had this 1 left over. The reason why we brought down a 0 is because I had this remaining 1. We brought down our 0, and now we're going to think, I have 10 hundredths. I need to break them into 2 equal groups. How many hundredths will I have in each group? I will have 5. Oh, that's right. Yeah, I had 5 hundredths here and 5 hundredths here. Now we do 5 times 2, which is 10. 5 times 2, I have 2 groups of 5. That is 10. We used 10 of our hundredths. Well, if we use 10 of our hundredths, and we started with 10 hundredths, what is our difference? Nothing. I don't have anything left here. So 5 tenths divided by 2 is 25 hundredths. As you can see, let's go ahead. When we divide 0.5, 5 tenths into 2 equal groups, what we're going to end up with in each group is 2 tenths and 5 hundredths. 2 tenths and 5 hundredths. In each group, we have 2 tenths and 5 hundredths. So that is the connection between this amazing process and then actually seeing what's going down when we're doing the modeling. That's really, really cool stuff. Let's check out another one. Whoa, buddy. Let's take a look. Oops, not with that. Let's take a look at this problem. 91 divided by 4. First, let's set up the problem correctly. We're just doing standard algorithm, you guys. We're just using the long division algorithm for this problem. We're not modeling. So 91 divided by 4. 91 is going to go inside the house of division. This little 91 goes inside the house because it's being divided. How is it being divided? It's being divided into 4 equal groups. 91 divided by 4. This is the most important part. Making sure that you set up the problem correctly. 91 is being divided by 4. 91 lives inside the house. 4 is hanging out outside saying, hey, please divide yourself into 4 equal groups. And 91 says, hey, no problem. Let's work together. Let's look at the first step. We're going to ask ourselves, we're going to look at this 9. How many 4s go into 9? 2. We can also think about, if I had 9 and I need to divide 9 into 4 equal groups, what would I have in each group with some left over? 2 in each group. Now we're going to do 2 times 4. 2 times 4 is 8. We're going to find the difference between 9 and 8. Don't think too hard. Thank you very much. Grayson is shouting out, it's 1, Mrs. Calamaris. And to that, Grayson, I say you are correct. So it's 1. Let's do our check here. Is 1 smaller than 4? Yep. Olivia's nodding her head. We can move on. Don't forget to do that check. If this number is not smaller than this number, we've gone wrong, and you would have to back up your tracks. But we're good here, so continue, okay? We're going to bring down our 1. Now we're looking at 11. If we have 11 and we need to divide 11 into 4 equal groups, what are we going to have in each group with some left over? Well, I'm going to have 2 in each group with some left over. If you need to go ahead and do some modeling on the side, please know that that is a tool that is super, super helpful. Okay? If you need a model, that's what this workspace is for. Use the tools and strategies that you need to support your learning. Okay, so now we have 2 times 4, which is 8. And now we're going to look at the difference between 11 and 8. The difference between 11 and 8, thank you very much, Violet, is 3. Is 3 smaller than 4? Zach is shaking his head. Yep. Cool. We can proceed. But there's no, oh dear, I don't have any numbers left. What do I do? We are going to make note that in 91, there are 0 tenths. 91 is not shown here with the decimal. You know the decimal is there though. We just we don't have 91 with the decimal because we didn't have any tenths, hundredths, thousandths. But we are going to go ahead and label the fact that there are 0 tenths. We're going to include our decimal, bring our decimal up, straight up, not to the side diagonal or diagonal. We're going to bring our decimal straight up. We're going to label the fact that there are 0 tenths here. And then we're going to bring our 0 down. Now we're looking at and thinking about the number 30. We have 30. It's 30 tenths for those of you thinking about place value. If we needed to divide 30 tenths into 4 equal groups, what would we have in each group with some left over? We would have 7. Notice how that 7 is right above the 0. Notice how the 7 is right above the 0 that we brought down. You see how everything's lined up in this beautiful column? Great. So now we have 7 times 4, and my writing is way too large. I've done it again. 4 times 7 is 28. The difference between 30 and 28, I'm going to move this over here. I'm so sorry that this isn't lined up. Bad, Mrs. Calamaris. I need to write much smaller. Is 2. Oh, you guys. Okay, so the difference here is 2. I still have something left over. We are no longer getting away with writing remainder 2. What we're doing is we're going to bring down another 0. What we're trying to do, what we're attempting to do, well, I'm working on drawing straight lines, first of all. I'm not doing the best job. We're trying to extinguish our remainder. We're going to keep going until we don't have a remainder. In earlier grades, you would just write, oh, it's 22, remainder 3. No, no more. We're going to add zeros into our tenths, hundredths, thousandths place value until our remainder is extinguished. So I'm going to bring down another 0. Now we're looking at 20. We're actually looking at 20 hundredths. And we're thinking to ourselves, and I'm sorry, this looks goofy down here, you guys. I wrote way too large, so please forgive me. So now we have 20 hundredths, and we're wanting to divide 20 hundredths evenly across 4 groups. What are we going to have in each group? Well, I'm going to have 5 hundredths in each group, because 5 times 4 is, I'm just going to talk through this. I feel like writing anything else is going to be mayhem. So 5 times 4 is 20. What is the difference between when we take 20 from 20? 0. We have our remainder is 0. So we then can say with confidence that the quotient, keep in mind the quotient is a fancy name for the answer to a division problem. The quotient when we divide 91 by 4 is 22.75. Fabulous. We're going to look at one word problem here. Okay, hamsters or calamari. Let's look at this word problem. I think it is really an interesting one. Let's change this name. Actually, let's change my ink color. We are going to go ahead and activate our RDW strategy for word problem solving. Read, draw, write, in that order. Let's go ahead and change this young lady. I'm sure she is very nice. Let's change this young lady to Kira. Hope you don't mind that I'm using your name, Kira. Okay, so Kira bought 6 gallons of apple juice. Kira loves apple juice. I don't know if you guys know that about her or not. After filling up 4 bottles of the same size with apple juice, she had 3/10 of a gallon left. How many gallons of apple juice are in each container? Okay, so with these problems, you guys, it is so important. Yes, read. It's important to watch this happening. If we can make sense of the problem, if we can imagine, okay, so Kira's coming home with tons and tons of apple juice. Maybe she went to an apple orchard with her family, and maybe, I don't know, maybe they made the apple juice themselves. So she's coming home with this huge 6-gallon container of apple juice, and it's so delicious. She's then going to share it by pouring it she's going to share it with 4 people. First of all, she's going to pour 1 bottle for me because she knows that I also love apple juice. Me. And then she's going to share 1 with Logan because he also loves apple juice. And then that one's for Logan. And then she's also going to share 1 with Emma because Emma loves apple juice. And then she's also going to share some with our very own Dylan. He is another apple juice lover. Okay, so she has 6 gallons of apple juice. She's going to pour 4. She's going to...
Excuse me?
Hi!
Hi, I have a student who forgot something. Is it okay if I send him out?
Yes. Yes.
Okay, thanks.
Sorry about that. That was Miss Dana. So she's pouring the apple juice into 4 bottles. All of these bottles, you guys, are the same size. After she pours the apple juice into the bottles, she has some left in her 6-gallon bottle. I can't imagine how heavy that would be. She has some left. She has 0.3 gallons left. Okay? We want to know how much apple juice are we getting? How much apple juice am I getting? How much apple juice is Logan getting? How much apple juice is Emma getting? We're all getting the same amount because each of these bottles, again, is the same size. So let's figure that out. First of all, I know that there's 0.3 gallons left in this 6-gallon jar. So let's think about that. So we're starting with 6 gallons. We are going to be left with, or I guess Kira is going to be left with 3.3 gallons left. She's going to have 0.3 gallons left in that 6-gallon jar. So let's go ahead and take 3/10 away from 6. Well, I can't take 3 from 0, so I'm going to have to go ahead and unbundle here. So our 6 becomes a 5 and our 0 becomes a 10. 10 minus 3 is 7. Go ahead and bring that decimal point directly down. And 5 minus nothing is 5. So what this tells us is that Kira poured 5.7 gallons across these 4 bottles. She poured 5.7 gallons across these 4 bottles. Ay, ay, ay. Hold on. Thank you. She poured, sorry guys, they have someone that forgot something. She poured 5.7 gallons across these 4 bottles evenly. So we have 5.7 gallons spread evenly across 4 bottles. I smell long division. All we have to do in order to find out how many gallons each of us is receiving is we need to divide 5.7 by 4. And again, it's 5.7 because we were told that she didn't pour all 6 gallons into the bottles. She saved, or she had left over 0.3 gallons. So using subtraction here, we know that there was 0.3 gallons left in the bottle. We were able to figure out that 5.7 gallons were spread evenly across the 4 bottles. Now let's figure out what is 5.7 divided by 4. Let's just go ahead and do some long division here. 4 goes into 5 one time, with some left over, of course. 1 times 4 is 4. 5 minus 4 is 1. Is 1 smaller than 4? Yep. Bring down the 7. Make sure we bring that decimal point straight up. Now we're looking at 17. If 17 tenths, this is being spread evenly across 4 groups, well, how many tenths will we have in each group with some left over? We will have 4. 4 times 4 is 16. 17 minus 16 is 1. I have a remainder. We're going to go ahead and extend our house of division. We're going to fill in the fact that we have 0 thousandths, and we are going to bring down the 0 so that we can extinguish that remainder. Now we have a 10. These are 10 hundredths. 10 is being spread evenly across 4 groups. What will we have in each group with some left over? We will have 2. 2 times 4 is 8. When we take 8 from 10, we are left with 2. Is 2 smaller than 4? Yep. I still have some left over. So now we're going to write in the fact that we have 0 thousandths. We are going to bring that 0 all the way down. And now we're looking at 20. We have 20 thousandths. 20 thousandths spread evenly across 4 groups. What will we have in each? We'll have 5 thousandths. 5 times 4 is 20. I've almost kept my work in the page. When we take 20 from 20, we're left with nothing. So what this has told us is that Miss C, I am the proud owner of 1.425 gallons of apple juice. And Logan also has 1.425 gallons of apple juice. Same with Emma and Dylan, and they are so happy. Thank you, Kira, for sharing with us. Secret word is apple juice. Secret word is apple juice. We are so grateful to Kira for sharing with us. I hope you guys have a great night. Can't wait to see you tomorrow.